You've seen it in sci-fi movies. You've watched it in anime. A train that floats above the tracks, streaking forward like a bolt of lightning, something ripped from the future. But what if I told you it's no longer fiction? In Japan, the future has arrived. The Maglev train doesn't roll on wheels, it hovers millimeters above the ground, racing at 500 kilometers per hour, faster than a jet at takeoff. And soon it will cover the 258.57 kilometers between Tokyo and Nagoya in just 40 minutes. But this groundbreaking technology comes at a price, over $80 billion and counting. With 90% of the route carved through mountains and deep tunnels, this is one of the most expensive and ambitious rail projects ever attempted. And despite decades of work, political battles, environmental concerns, and skyrocketing costs threaten to bring it to a halt. So how does this train float above the tracks, and what makes it faster than anything before it? Japan's major cities are some of the busiest in the world. The stretch between Tokyo, Nagoya, and Osaka is the economic lifeline of the country. More than 60 million people live here, and this region fuels Japan's finance, industry, and culture. With millions traveling across this corridor every day for work, tourism, and daily life, the pressure on existing transportation networks is immense. For decades, the Shinkansen has been Japan's answer to high-speed travel. Introduced in 1964, this world-famous bullet train revolutionized rail transport with its precision, safety, and efficiency. The Tokaido Shinkansen alone carries over 450,000 passengers daily, moving at speeds of up to 320 kilometers per hour. It's fast, it's reliable, but it's also reaching its limits. Trains already run every few minutes, often at full capacity. The sheer demand is straining the system, and even Japan's famously punctual rail network is feeling the squeeze. Delays, though rare, are becoming more frequent, and during peak hours, the sleek high-speed experience can feel more like a packed subway ride. Japan needed a new solution, one that could drastically cut travel time, ease congestion, and push the boundaries of modern rail transport. The answer? A train that doesn't touch the ground. Magnetic levitation, or Maglev, is a complete reimagining of high-speed rail. Unlike traditional trains that rely on wheels grinding against tracks, Maglev systems use powerful superconducting magnets to lift the train off the guideway. No friction, no wear and tear, just pure, smooth acceleration. Japan has been working on this technology since the 1970s, starting with a small 7-kilometer test track in Miyazaki. As the technology advanced, so did the scale of testing. A 42.8-kilometer track was built in Yamanashi Prefecture, setting the stage for something much bigger. The goal? To connect Tokyo and Nagoya in just 40 minutes. And that's just phase 1. The full vision extends the line to Osaka, reducing travel time between the two megacities to 67 minutes, less than half of what a standard bullet train takes at nearly 3 hours. This isn't merely an upgrade, it's a transportation revolution. After decades of development, Japan officially broke ground on the Chuo Shinkansen Maglev line in 2014. The plan was ambitious, launched by 2027 and changed the way people travel forever. But how do you build a train that floats on air? Building a Maglev train isn't like constructing a regular railway. Unlike traditional high-speed trains, which rely on steel wheels and tracks, this train levitates above the guideway using superconducting magnets. That means an entirely new infrastructure is required: dedicated tracks, advanced magnetic coils, and massive underground stations. And here's the real challenge. This train won't just glide at record-breaking speeds of 500 kilometers per hour. It also has to cross mountains, navigate seismic zones, and bypass some of the most densely populated urban areas on the planet. How do you build an ultra-fast railway in a country where land is scarce and natural disasters are a constant threat? The first phase of the Maglev line, stretching from Tokyo to Nagoya, covers 286 kilometers. Instead of following the traditional coastal route of the Tokaido Shinkansen, this new railway carves a straight, high-speed path through the heart of Japan. But here's the catch: 90% of it is underground. Why take the difficult underground route? The answer lies in speed and efficiency. High-speed trains perform best on straight tracks, free from sharp curves or congestion. By tunneling through the mountains rather than weaving around them, the Maglev can maintain top speeds without slowing down. But making this happen is easier said than done. To create this direct path, engineers have had to cut through the Japanese Alps, some of the deepest and most geologically complex regions in the country. Some tunnels extend more than a kilometer beneath the surface. But tunneling at such depths is risky. Japan is one of the most seismically active countries in the world, meaning the Maglev must be built to withstand major earthquakes. To address this, engineers have designed reinforced tunnel linings, shock-absorbing support structures, and real-time seismic monitoring systems that can halt operations in an instant if movement is detected. One of the biggest concerns? Water disruption. In Shizuoka Prefecture, tunneling could lower the Oi River's water supply by 2 metric tons per second, threatening agriculture and local livelihoods. This has led to political disputes and delays as local officials refuse to approve construction without guarantees that water levels won't be impacted. Beyond the tunnels, the train itself is a technological marvel. But what makes it so special? The Maglev operates using superconducting magnets, cooled to extreme temperatures to generate a powerful repelling force between the train and the guideway. The result? The train hovers 100 millimeters above the track. No wheels, no friction, just pure speed. And when we say speed, we mean it. At a staggering 500 kilometers per hour, this train is faster than most commercial airplanes. Passengers don't feel the usual jolts and vibrations of traditional trains. Instead, the ride is so smooth it feels like floating on air. But there's more. Unlike conventional rail systems where constant wear and tear on the tracks drive up maintenance costs, the Maglev's frictionless design minimizes long-term upkeep. But with great speed comes great energy demand, and that's where the challenge begins. The Maglev consumes 3 to 4 times more energy per passenger than the existing Shinkansen. Can Japan's power grid handle such an energy-hungry system, especially in the wake of nuclear plant shutdowns? That question has fueled heated debates about the train's long-term sustainability. For all its technological promise, the Maglev project has been met with intense criticism. The biggest concern? The cost. When first proposed, the budget was set at around $50 billion. But as construction progressed, the number skyrocketed, blowing past $80 billion, with some estimates now creeping toward $90 billion. What's driving these soaring costs? A mix of unexpected geological challenges, inflation, and the sheer complexity of the project. And while JR Central is footing much of the bill, the Japanese government has stepped in with multi-billion-dollar low-interest loans, effectively putting taxpayers on the hook. But where is all this money going? The biggest expense is tunneling, which accounts for nearly 90% of the Tokyo-Nagoya route. To carve a path for the Maglev, engineers are drilling deep into the Japanese Alps through some of the toughest rock formations imaginable. Excavating at these depths is slow, expensive, and full of surprises. And to make matters more complicated, seismic reinforcements and the construction of underground stations have only added to the cost. And then there's the question of energy consumption. Speed comes at a price, and the Maglev demands 3 to 4 times more energy per passenger than the existing Tokaido Shinkansen. In a country already grappling with energy constraints, is this level of consumption truly sustainable? Critics worry that keeping the Maglev running at full speed could strain Japan's power grid, especially as the nation shifts toward renewable energy sources. But the environmental impact, that's another major controversy. The extensive tunneling work for the project is generating millions of cubic meters of excavated soil, much of it laced with arsenic, mercury, and other toxic chemicals. So where does all this waste go? That's the problem. Disposal sites have sparked outrage among local communities, who fear that improper dumping could contaminate groundwater and trigger landslides. And the concerns don't stop there. In Shizuoka Prefecture, the stakes are even higher. The Oi River, a crucial lifeline for thousands of residents and farmers, could see a drastic drop in water levels due to underground tunneling. How bad could it get? Studies suggest that up to 2 metric tons of water per second could be diverted away from the river. That's a massive shift, raising fears of droughts, failed crops, and financial ruin for local farmers. Local officials aren't taking any chances. They've blocked construction in Shizuoka, demanding ironclad guarantees that the river's water supply won't be compromised. But despite government reassurances, opposition remains fierce. And the delays? They're piling up fast. Some experts now believe the Tokyo-Nagoya segment won't be completed until at least 2034, while the full Tokyo-Osaka route could be pushed all the way to 2045. The Maglev may be a technological marvel, but will it actually make money? That's the billion-dollar question. The cost of operating and maintaining such an advanced system is staggering, and experts worry that ticket prices could skyrocket. If fares become too expensive for everyday commuters, ridership might fall short of expectations, turning this high-speed dream into a financial nightmare. And then there's Japan's shifting demographics. With a declining population, the number of commuters and business travelers is expected to shrink in the coming decades. So, will there even be enough passengers to justify the eye-watering investment? But perhaps the biggest question of all, does Japan even need this? The country already has one of the best high-speed rail networks in the world. The Shinkansen is fast, efficient, and reliable. It connects cities seamlessly without the extreme costs and risks of Maglev technology. Despite all the challenges, Japan is still pushing ahead with the Maglev project, hoping to prove that this technology is the future of high-speed rail. If successful, the Maglev could serve as a blueprint for other countries looking to build ultra-fast rail networks. Japan has already tried to export the technology to the US, with proposals for a Maglev line between Washington, D.C. and New York City. But will other nations be willing to invest in such an expensive and complex system? Some argue that Japan's Maglev might ultimately be more of a technological showcase than a practical solution. While the speed is impressive, the costs and environmental concerns raise serious questions about whether this model can be replicated elsewhere. Still, the dream remains. A future where cities are connected by near instantaneous travel, where long commutes become a thing of the past, and where rail transport outpaces even air travel. Let us know what you think in the comments below. Is the Maglev train the future of travel, or is Japan investing too much in a technology that might never pay off? And if you enjoyed this deep dive into one of the world's biggest mega projects, don't forget to like, subscribe to Ultimate Mega Builds, and hit the notification bell for more content like this.